Hi guys! We are in our last chapter of this semester, or even your last chapter in 10th grade. Okay? So, our last chapter is vector. Okay? Before this, I gave you a short video about what vector is and what is the difference with scalar and a glimpse of how to describe a vector and its application in real life. A very interesting video, I think. I hope you found it interesting too. Okay, so about vector itself, you have learned about it in physics. Some of it, its notation, its meaning, or maybe some of its formula. So it's quite familiar for you. Okay, so now let's start our lesson about vector. Okay, so what will you learn in this chapter? Okay, in this chapter, you will learn about the basic concept of vectors and the general properties of vectors and its application in simple geometry. Okay, you will learn about the basic things in vectors here. Okay, the definition of vector. A vector is an object that has both a magnitude and a direction. Okay, while scalar only has a magnitude. Okay, geometrically, we can picture a vector as a directed line segment with direction, whose length is the magnitude of the vector, and an arrow indicating the direction, like this one, for example. Vector AB. The direction is from A to B. Point A is tail of the vector. Point B is head of the vector. Okay, and this vector is denoted as, you can start from the tail of the vector to the head of the vector, AB with an arrow on top of it, showing the direction, or just simply say it's vector U. Or some books write vector in a bold letter. Okay, but it's kind of hard for handwriting, so it's common to use arrow on top of the letter. Okay, so this is the definition of vector. Okay, so how to write a vector? Let's just say that I have this vector A, B. Writing a vector is like show your way when you want to move from one point to the other. In this case, you want to move from A to B. So you move 4 units to the left, to the right, and 3 units up. Okay, so from A to B, you have to move 4 units to the right and 3 units up. Okay, now to write this vector, you can use this array, vector A, B. You write it like this: 4 units to the right, horizontally, 3 units to the up, vertically. Okay, this is what we call column vector. Okay, or in coordinate Cartesian, for horizontal direction is for x direction, vertical direction is for y direction. Okay, or you can also write it in an arrow vector, like this. Okay, but I prefer to do it like this, in a column vector. Okay, the first number represent the movement in the x direction. The second number represent the movement in y direction. Okay, to the right is positive, to the left is negative, up positive, down negative. Okay, this is the notation of vector. Okay, so now how to write vector in 3 dimensions? Okay, you are used to coordinate Cartesian in 2 dimension, and now we will see how coordinate Cartesian look in 3 dimension. Okay, this one, forward is for x direction, left horizontal direction is for y, and vertical is for z. Okay, so moving forward is for x positive, backward x negative, to the right is y positive, to the left y negative, up z positive, down z negative. Okay, so this is the coordinate Cartesian in 3 dimension. Okay, so now let's see how the vector is written in 3 dimensional. Let's just say that I have this one, vector df and vector fc. Okay, how to write vector df? Okay, vector df inside a box like this with its length is 9, its width is 6, and its height is 4. Okay, just picture df in a box whose width, length, and height is 9, 6, and 4. Okay, now vector df is written like this in x direction, y direction, z direction. Okay, so vector df, we want to move from D to F. Okay, first x direction, we move forward 6 units. In y direction, we move to the right 9 units. And in z direction, we move up 4 units. So vector df is 6, 9, 4. Okay, for vector fc, we want to move from F to C. Okay, again, first one is x direction. We move backward 6 units, so it's -6. In y direction, 0. And in z direction, we go down 4 units. So fc is -6, 0, -4. Okay, this is how we write vectors in 3 dimensions. Okay, now let's see about vectors magnitude. Okay, vectors magnitude. Magnitude of a vector denoted like this with an absolute symbol like this. So if you see this symbol, it means that it's the length of the vector of the magnitude of a vector. And how to find the magnitude of a vector? Okay, let's see this example. If I have a vector a, b, 4 units to the right and 3 units up. Okay, now the length of this vector is a distance from A to B. As you can see, this one is a right triangle, right? Where AB is the hypotenuse of this triangle. So to find the length of AB, you use the Pythagorean theorem of 4 square, the square root of 4 square plus 3 square. Okay, so the magnitude of the vector can be written as like this. If vector O is x and y, then the magnitude of a vector is square root of x squared plus y squared. Okay, and in 3-dimensional, it's also the same. The magnitude of vector, let's just say vector p is x, y, and z. So its magnitude is square root of x squared plus y squared plus z squared. Okay? Okay, unit vector. What is unit vector? Unit vector is a vector whose magnitude is equal to 1. And its notation is like this. So instead of an arrow, we put some like a hat on top of it. Okay, so unit vector, its magnitude is 1. How about the direction? Okay, let's see. For example, I have vector v from A to B, 4 units to the right and 3 units up. Okay, this is vector v. Now, unit vector is a vector whose magnitude is equal to 1 and the direction is the same as vector v. Okay, so we find the vector whose direction is the same as vector v, but its magnitude is equal to 1. Okay, before we go to that, let's see. Vector v itself, the magnitude is equal to 5. The length of vector v is equal to 5. Now we want to find the unit vector with the same direction as vector v, but the length is only 1, like this one. How to get this? Okay. How to get this? Right. You just divide the vector by its magnitude by 5. Then you get a unit vector with the same direction as v, and the magnitude is 1. Okay, so in general, the unit vector is 1 divided by the length of the vector multiplied by its vector. Okay, this is the unit vector. Okay, and unit vector in x direction in coordinate Cartesian, we write it as I, y direction as j, and z direction as k. Okay, this is the unit vector in coordinate Cartesian. Okay, after learning the unit vector, now we can write a vector in its basis vector like this. Okay, like this. Vector u, xy equals to x, I plus yj. I for x direction, unit vector in x direction, j for unit vector in y direction. Okay, in 3-dimensional, you just add one more in z direction, z. Okay, for example, it's like this. Vector u 2, negative 1, 8 equals to, in its basis vector, it is written like 2i minus j plus 8k. Or vector in its basis vector can be written like this. 5i plus 8k, so there's 0j here, so 5, 0, 8. Okay. Okay, position vector. In Indonesia, vector posisi. Representation of the vector from the origin to the point. Like this one. Okay, for example, this one, the starting point is from the origin and the ending point is a point K, and its coordinate is 5, 2. Okay. The position vector for this can be written like this. All K, or just K with a small letter. Okay, this one indicates its vector, position vector. Okay, so in general, if coordinate of a point P, x, y, then its position vector is P, small letter, or OP equal x, y. Okay, this is position vector. Okay, equal factors. Two factors are said to be equal if and only if they both have the same direction and equal length. For example, like this one. Okay, all of these vectors have equal length but different direction. The one that has the same direction is only A and B. So A and B are set to be equal. Negative vectors. Negative vectors are vectors with equal length but in opposite direction, like this one. Okay, so vector BA is equal to negative AB. Okay, displacement vectors or vector perpindahan in Indonesia. Displacement is a physical quantity used to represent change perpindahan in position vector of an object when it is moved from one location to another. Okay, let's just say that I have these two vector position OP and OQ. OP 5, 2, OQ negative 3, 5. Okay, we want to find vector PQ. It's like we move from P to Q. Okay, from P to Q, we move 8 direction to the left and 3 direction up. Okay, so vector PQ is negative 8, 3. Okay, in other way, we can find vector PQ using a vector displacement like this. Okay, PQ equals vector position of Q subtracted by vector position of P. So PQ equals Q minus P. Okay, PQ is vector position of Q is 3, 5, negative 3, 5 subtracted by 5, 2. Okay, we subtracted arithmetically negative 3 subtracted by 5, negative 8. 5 subtracted by 2 equals to 3. Okay, so x minus x, y minus 1. Therefore, we get the vector PQ by using displacement vectors. Scalar multiplication of a vector. So what happens if a vector is multiplied by a scalar? Scalar means any number. Okay, so if I have vector u 2, 1, so if a vector multiplied by 2, so you just multiply each of its component by 2. If a vector multiplied by 3, so you multiply each component by 3. Okay, and so on. Okay, in general, we can say that if vector b equals to k times vector a, while k is a scalar, a number, if k is positive, then a and b are in the same direction. If k is negative, then a and b are in opposite direction. Okay?